Day 5, Monday, November 4th, and we have been working on multiplying binomials. Okay, we've done the FOIL method and we've done the box method. So for your do now today, I had you solve 4 problems like this. So let's work these out together and see what we all did. Number 1, I've got x plus 2 times x minus 3. Does somebody want to tell me what they did to solve this? Box method? Okay, so let's try the box method for number 1. Maybe we'll do FOIL on the next one. I'm going to start by drawing myself a box with 4 open slots. Okay. And what should I write on top?
First box, on top of the first box, plus 2 on
Yeah, plus 2. And how about the side here?
X and then negative 3.
Good. X and negative 3. So what am I going to fill in these boxes with?
X times X.
Good. X times X is what?
X is
X squared.
X times 2.
X times 2, what is that?
2X.
Good. I'm going to write plus 2x. And how about we start down here now? What is x times negative 3?
Negative 3.
Good. Negative 3x. And last but not least, negative 3 times positive 2. Negative 6.
Oh, no.
Now, is there an x on either of these terms? No, there's not. So we don't need an x on negative 6. We're just taking negative 3 times positive 2. Okay. Is anybody confused about how we got to this point so far? Are we all feeling okay?
I wasn't really learning, but I got the answer.
Okay, good. All right, so this was just a new method. It's the exact same thing, just a different way of solving it. So what am I going to do with this information?
Like terms.
Yeah, I want to see if I have any like terms. I've got some right here. I've got a positive 2x and a negative 3x.
Negative 1x.
Yeah, so 2 plus negative 3 is negative 1. So I know I'm going to have a negative 1x. And what do I do with the rest of my terms?
X sides to the second power.
Yeah, x squared minus 1x minus 6. Perfect. And that would be my answer. However, a more simplified version of that would be x squared minus x. We don't need to write the 1. Anytime we've got a 1 next to a variable, we don't need it. Minus 6. So this would be your answer. Did anybody get something different? And if you did get something different, do you understand how this is the answer?
So we'll be getting it wrong with the 1x.
Eventually, once I start asking you specifically to simplify your answer, it would be counted not completely wrong. You could get like a point or 2 off. But for now, I'm more worried about making sure we've got this process down. So if you put minus 1x, that's not wrong. I'll let you know when I am going to be looking for that. Okay. Any questions about number 1 before we do 2?
I put 9 as 1, but when I looked at what I just did, I seen that my multiplication at the top was wrong, so I erased my negative 1 and put the minus 6 instead. But for both, I guess. Yeah, I got both, I guess.
Okay, so which part?
The top, the bottom, negative 3 times positive 2.
Oh, were you at minus 6 here?
Yeah.
What did you get the
right
first
there,
time
first
around?
I had 1.
You got 1?
Yeah, first. Yeah.
Oh,
but
did
minus
you?
1.
Okay,
Yeah.
so you added instead of multiplying.
Yeah.
I get you, girl.
I caught it.
You did. I love that. I love it. That's awesome.
Yes, indeed.
You guys are awesome. Okay, we ready for number 2? How about this time we do the FOIL method since we just did the box method? You can do a little mixing it up here. So if I am using the FOIL method, what is my first step? Yeah, x times x, which is x squared. And what's my next step?
X times negative 4.
Good. X times negative 4 is what? Negative 4x. Then what do I do?
Negative 5 times x.
Good. Negative 5 times x is?
Negative 5x.
Good. Negative 5x. And last but not least?
Negative 5 times negative 4
is?
Positive 20.
Yes. Oh, you guys rock. Positive 20. Two negatives make a positive when we multiply. So very good job. Are we done here? No. What should I do next?
Add negative 4 plus negative 5.
Yes. What is negative 4 plus negative 5?
Negative 9.
Good. So I'm just going to rewrite that middle term. Negative 9x plus 20. Is this my answer?
Yeah.
It sure
X
is.
squared.
Oh, my bad. You caught me. Thank you. I wasn't trying to trick you. I just messed up. My bad, guys. Thank you. So that is our answer, and we circle it. Any questions on number 2? Any questions? The floor is yours, guys. I'm happy to answer.
No.
Start struggling with the negatives.
Oh,
Yes.
that's all right. I think the more we do it, the better we get at it.
I turned it to
I just
positive.
wrote a
It's
whole
two negatives to make a
Oh, okay, yes.
Yeah.
It's all right. If we were multiplying, that'd be right.
Yeah, that's right.
Yes.
You know me.
I know.
So,
Mm,
I got 2 wrong.
that's okay. All right. Any other questions or things we noticed about number 2? We want to go to 3?
Yes.
Let's do it. Okay. Number 3. I threw in a number attached to your x this time. We've got 2x plus 4 times x plus 12. Who wants to walk me through this? Raise your hand. Michael, what'd you do?
I did the FOIL method, I did 2x times x gives me 2x squared.
Perfect. 2x squared. Then what'd you do?
2x times 12 gives me plus 24x.
Good. Plus 24x. Then what?
4 times x gives me 4x.
Good. Plus 4x. And last but not least,
4 times 12 gives me 48.
say that again. 84?
48.
48. Perfect. 48. All right. So you got this far. What'd you do next?
20. I put 24 plus 4 gives me plus 28x.
Good. 24x plus 4x is 28x. And what'd you do after that?
The answer is 2x squared plus 28x plus 48.
Good. 2x squared plus 28x plus 48. Did everybody get that answer? Awesome. Awesome. You guys are doing so good on this. Any questions? Yes.
Somehow I got negative 28. I don't know how I did that though.
Negative
You
28.
probably wrote it down.
Yeah, what's your original problem say for number 3?
It's just like 2x minus 28x plus 48. I don't know if I just accidentally did put the plus sign or something.
Yeah, it sounds like that was probably just a silly mistake. Maybe you just forgot to make it a plus instead of a minus, because we've got all positive numbers here in our original problem. So we shouldn't be getting any negatives unless we just accidentally wrote a negative in. So I have a feeling that's probably what happened there. Anything else with number 3?
Yes.
Uh-huh.
I got everything up to 48.
Sure.
How 4?
4 times 12.
So for our last terms here, we're doing 4 times 12. And when we do that, we get 48.
All right, my math was off.
That's okay. All good. All good. Okay. Anything else, guys?
Yeah, I need to learn how to do mathematics.
Star. Where are you messing up on this one?
It was just a stupid mistake. 2 times 12. I put 22 instead of 24.
I gotcha.
See, I can't even.
That's okay. And you know what? I'm going to suggest this to you and every other person in this room. We just need to Slow down. Take every step slowly. Because when we get quick and excited and we're like, oh yeah, this time this is this, and just go fast, that's when we make our mistakes. We want to go step by step, slow it down. We can also, the multiplication charts. Very good to look at that. Check your answer. You also got calculators. Use them. They are tools for you guys. All right. Are we ready for number 4? All right, let's do number 4. I got 3x squared plus x times 4x minus 3. What do we do first?
We do 3x squared times 4x.
Good. 3x squared times 4x.
12x to the third power.
Yes. 12, because 3 times 4 is 12. X squared times x is x to the third power. Good. What's next?
3x to the second power times negative 3.
3x to the second power times negative 3 is what?
Negative 9x squared.
Negative 9x squared. Is anybody confused about how we got this?
I put negative
I
5.
couldn't figure out what my answer was on the paper, but I got it right. I'm using the box method.
Yeah. Well, here, we can draw the box out too. Because we just did 2 with foil. Let's do 2 with boxes. Okay, let's try this again. I'm going to write it out. I got 3x squared plus x. And then I've got 4x. Let me move this down a little. Minus 3. Okay, so we're going to do it both ways. So we just got 3x squared times 4x was 12x to the third power. Then we did 3x squared times negative 3.
9x squared.
Negative.
Oh, yeah.
Negative 9x squared. Good. And
Now you do 4x times x.
yep, 4x times x.
Is 4 to the second power.
4x squared. Perfect. So is that positive or negative?
Positive.
Positive. Good. So I'm going to write this out here too. And last step.
Negative 3 times x is
Good. Negative 3 times x is negative 3x.
I did this. So it's not to the second power.
No. So why is it just negative 3x? Why isn't it? Yeah. We're just taking negative 3 times an x, just x to the first power, invisible first power. So we're not multiplying any other x's, so that just stays an x.
That's on part I wrong. I put it because those
Well, that is pretty good for only getting that part wrong. This is a tricky one, so I'd be happy with that. That's good. Okay, guys, so we've got all of these terms written out. Here it is with the FOIL method. Here it is with the box method. What do we do now? Yes.
5x squared.
We want to combine our like terms, and I heard a few people say it.
Negative 5x.
Absolutely. So our answer, I'm just going to write it out down here. 12x to the third power minus 5x squared minus 3x. And that's your answer.
Everybody wins.
Yes. Okay, before we get too excited and move on to the next thing, I do want to ask you guys, does anybody have questions about any of this? I'm happy to answer. Are we ready to move forward? What'd you say, Abby? Get it, girl. That's awesome. I love it. Okay, guys. Here's what we're going to do today. I'm going to give you a little sneak peek. We are getting into this stuff. We're getting into it. We're going to learn what a factor is. We're going to learn what a quadratic expression is. It's a scary word, but I promise you guys it's not scary. I'm gonna make it so it's not scary.
Four.
Yes, quad is 4.
So we're doing by what? So it'll be 4.
Doing blocks.
You'll see. And I wrote in parentheses here parabola. And I'll tell you what that means later.
That sounds nice.
And once we've messed with the top 2 topics, we are going to learn how to factor quadratics. That sounds really crazy and scary, and I promise you it is not, as long as we take it step by step, as long as we pay attention, you're listening, you're following along. We got this, guys. Factoring is just the opposite of what we just did for the last couple of days, and y'all got this, so I know you guys are going to have this next thing. So I'll give you guys a minute to just get adjusted, get a piece of note paper out, get ready to focus. We're going to lock in here in a minute and get ready. We're going to talk about some important stuff. So, move my sticky notes. Okay, so here is how I'm going to have us start our next page of notes. I just put day 5 continued. That's just how I title my notes. You guys don't have to do it the exact same way. That's just what I like to do. And first, we're going to talk about, before we get into the process, I want to make sure we understand every little bitty baby step of the way what a factor is. What is a factor? Does anybody know what a factor is? Say it again. It is a number. It is a number. You're on the right track.
What X, the X.
Could be with a variable. Could be with an exponent. It could be a binomial.
Wait, like.
What an equal sign?
What X means?
It won't have an equal sign. It's not what X means.
Solving the
But if you
problem?
break
The
a number
answer?
down, if
Kind of. Say that again, Michael.
you break a number down into its equal, like we're all equal numbers adding up to that,
An exponent.
Very close. Not adding up to it.
or times.
Yes,
Yeah.
multiplying up to it. So guys, a factor is just how you can break a number up into the parts you multiply together to get that number. So I'm going to give you a definition and I'm going to give you an example because that might sound like gibberish to you right
So
now.
they say how many numbers are factor into this number, so what times what is going to add to how many of those
Yes.
actually go into what the number actually could be. Oh.
Yes.
Like the square root of 7.
Okay.
Or like
Yeah.
the square root of
5.
49. Yeah, so like if I was asking you what are the factors of 49, you could say 7 and 7 are factors of 49. It's just numbers that multiply to make a number. So what is a factor? It is
The whole numbers?
the whole numbers, or it basically the numbers that you can multiply without having remainders. So usually it's going to be whole numbers. For now, we're talking about whole numbers. Yes. So the numbers you multiply together. Yeah. Spelling, guys, come on.
Your math teacher.
Yeah, I don't teach English. The numbers you multiply together to get a product. Your answer. So, for example, I'll give you guys a second to write. I'm going to write down here. Example. Let's say I'm looking at the number 12. And I want to know all the factors or all the numbers that I could multiply to get 12. So I always like to start with 1. You can take any number times 1 and get that number. Those are factors. So 1 times what makes 12? 1 and 12. Good. Then let's count up. Yeah, 2 times, I heard you say it's 6. Makes 12. Good. 3 times 4 makes 12. And then if we go any further, we're just going to get the opposites of these. 4 times 3 is 12. 5 times, can't use 5 because it doesn't fit into 12 equally. Then 6 times 2, 7 doesn't fit. 8 doesn't fit. 9 doesn't fit. 10 doesn't fit. 11 doesn't fit. 12 times 1. We fall right back into the same thing all over again. So here's our positive factors. Are there negative numbers that could be factors too?
Yes.
Yeah, absolutely. So instead of 1 and 12 being multiplied, what could I multiply together to get positive 12 still?
-1.
Yes, I could also do -1 and -12.
Because a negative times a negative is positive.
Yes, two negatives, when you multiply them together, it gives you a positive number. So I could just copy these down and use the same numbers. -2 times -6 makes positive 12. -3 times -4 makes positive 12. So when you're factoring something, all you're doing is trying to figure out, what do I multiply together to get that number? You're just coming up with the possibilities. So we're going to go a little further with this though, because we're not just factoring a 12, we're factoring some bigger things. What if I, just for fun, what if I wanted you to factor x to the 5th power? What are some things that I could multiply together to get x to the 5th power? We can start with 1.
1.
Yeah, so 1 times what makes x to the 5th power?
1 times x.
X to the 5th.
Yeah, 1 times this number, x to the 5th power. That's going to give me x to the 5th power. Anything times 1 is itself. So 1 is always a factor, always. Now, we're probably not going to be looking at number factors here. Instead, let's think about when we multiply exponents, what do we do exactly? You're adding them. You're adding them. So let's start with x. Remember, that's like x to the 1st power. What would I multiply that by to get x to the 5th?
X plus 4.
X to the 4th power. Because 1 plus 4 is 5. You guys see that?
Yeah.
What about x to the 2nd power?
To the 3rd.
X to the 3rd. Good. And if I kept going, I would have x to the 3rd, and it would just flip-flop. X to the 3rd times x to the 2nd. X to the 4th times x to the 1st, and it could go on and on and on. Okay, so if you guys are able to do this part, that's excellent. I think we're ready for the next part. So we know what a factor is. It's just multiplying numbers to get a final number. Now we're going to learn what a quadratic expression is. So let's make a little chart of what that is. I want you to label your page quadratic expressions. Can I move this down, or does anybody still need these factor tables? Okay, thank you. So, little do you know, what we've been doing the last few days, we've been doing very purposefully to prepare you for this. So, you might not know what this word means, quadratic expressions, but you've actually been working with quadratic expressions for the last few days. So, a quadratic.
And then would those be like the 2x minus 3, and then your other 2, those are what those are?
Very close. So whenever you multiply the things that we were doing, those binomials, those x plus something or x minus something, when you multiply those together, you get a quadratic expression. So here's what a quadratic expression is, and I'm going to kind of color code this. And whenever you see A, B, and C in this expression, that's just standing for a number we don't know. So a quadratic expression is like this. We have an ax squared plus bx plus c. This is what a quadratic expression looks like. And if you notice, like in your do now, all of our answers look like that. It's something x squared with an x next, and then a constant or a number that doesn't change with no variable. Same thing here. We got like a 2x squared plus 28x plus 48. That's a quadratic expression. We're just giving a title or a name to these problems we've been working with already. So, grab my little notes here. We're going to talk about this a little more. So, whenever we are working with quadratic expressions, first of all, and what is this going to do? Like, what are we using this for in math? Now, I'm not going to give you the full rundown spiel of how we use this yet. I'm just going to give you a little sneak peek. So, whenever we are graphing a line, does anybody remember what that equation looks like? Yes, that is the slope of it. What's the
in your y?
Y equals mx plus b.
Yes. So y equals mx plus b. And you don't have to write this part. I'm just going to, unless you want to, this part I'm just kind of giving you some background to understand how this is going to be used eventually. So whenever we have this equation, it gets graphed on a line like this, something like that. This is our y equals mx plus b. It's just a line. But whenever we graph a quadratic equation, we get something that looks like this.
Oh.
This is a parabola. This is a parabola. Now, don't be scared. We aren't going to touch graphing this for a while. I just want you to know that eventually we're going to get to this point. Once we know how to solve for x, that's what we're going to learn today. So this is a parabola. They can go upward like this. They can go downward. It all just depends on what the numbers are in the equation. So
Lines on either side have to be equal, right?
Say that again.
The lines on either side have to be equal, right? Like on the sides of the U.
Yes. So fun fact about parabolas, they have an axis of symmetry. So once you've found points on this side, you already know all your points on that side. I promise you, graphing these is not as scary as it looks. You find this point, your vertex, then you find like 1, 2, 3 other points, and then it just makes itself. It won't be difficult when we do it. I promise. I'm gonna guide you through it. All right. So there's our sneak peek. Let's learn about putting factoring into a quadratic expression. We're going to learn how to factor this and figure out what we multiply to get this. So I'm going to flip the page, and we're going to create a little guide together. Does anybody still need this? Okay. So this is day 5 continued, page 3 of our notes. I'm going to title that Day 5 continued. Three. Okay, so here is what I would like for you to title your guide. We're about to make a step-by-step guide. Let's see if I have a marker I can use. All right, we are going to title this page Factoring quadratic. You could abbreviate that to quad if you wanted to. It's a long word. I'm going to write it out though, for fun, I guess. Quadratic expressions. And this guide is only going to work when A equals 1. And I will tell you what that means as well. Promise I'm going to explain every little step. So make sure you write when A equals 1 because there's different rules whenever A is something else. So one more time, I'm just going to copy down that AX squared plus BX plus C so I know what we're talking about. AX squared.
Now, this one where it has to be the small a, we're not doing capital, right?
Yes,
Okay.
this is little a. This isn't like slope and all that. This is different. Good question though. And I'm going to get my laptop charger before it dies on me. Okay, so whenever we are factoring quadratic expressions, we're finding the two things that we can multiply together to make this. Let's talk about it. First of all, this method will only work whenever we just have x squared at the beginning and there's a 1 here or no number, assuming that there's that invisible one, okay? We're only going to talk about that type today. There's not going to be a number in front of our x squared today. So if you notice, whenever we are multiplying our binomials, we always get an answer that looks like this. So we know that the factors have to be x plus or minus something times x plus or minus something. That's going to be what we're filling in. So step 1 is to draw empty parentheses. Now where'd my black pen go? Okay, just going to write in blue. Plus or minus something times, it's not be a number, x plus or minus another number. Looks scary, promise you it won't be. Make it really easy. So there's your first step, is we get our empty parentheses out. Now, step 2. We need to figure out what these numbers are going to be. So I'm going to show you how we do that. First, I'm going to label my step 2, just so we can have a little guide to look back at. So step 2, I'm writing, find the numbers. To fill your parentheses. So here's how we're going to know what those numbers are. And this is going to make much more sense when we use an actual problem. Right now we're speaking hypothetically. So if you're a little lost, I promise you will feel found once we put numbers in here. So bear with me for a moment. To figure out what these numbers are, we need to find two numbers
3.
This is still kind of part of step 2. Part of step 2. We are going to find two numbers that multiply to C and add to B. And I promise I'm going to make this super simple. I was scared whenever I first looked at this and was trying to learn it for you guys, but I found a really easy way to do it. A really easy way. You guys are going to think it's so easy. And that's basically it. There's really just 2 steps. So once we have these steps written down, we're going to do an example together. And I'm going to show you before I have you try it. Pause it. And go. Here's our first example. We are going to start with x squared plus 7x plus 12. So the first thing that I'm going to do once I have my expression written out is I'm going to label my A, B, and C. So A, because there's no number next to x squared, what does that make our A? 1. So that means we can use this method. A equals 1, so we're good. What is our B? 7. So that's the number next to x. And what's our C?
12.
12. That's our constant. So we've got it written out. Step 1 was to write our 2 empty parentheses. So let's do that. Let's just write. We know our answer is going to be x plus or minus something times x plus or minus something. And here's how we're going to figure it out. In step 2, it says that we need to find 2 numbers that multiply to C. So what 2 numbers, or not what 2 numbers, you don't need to know that yet, but what are we trying to multiply to? 12, because that's our C. So let's just worry about that first, not the adding yet. So if I want to know what numbers multiply to 12, we actually did that earlier. Remember, we did our factoring chart. So let's just redraw that chart. First, we want to find our factors of C. So I'm going to make a little T chart every time. This is how I'll do it. I can multiply 1 times 12 to get 12. I can multiply 2 times 6 to get 12. And 3 times 4. Good. All right, so I've got my factors. So done with that part. I needed to find numbers that multiply to C. Here's my numbers that multiply to C, or 12. So now we need to figure out which of these sets of numbers are also going to add up to B. Our B is what? 7. So all we need to do is go down this line and see what the numbers add up to. What is 1 plus 12? 13. Okay, what's 2 plus 6?
8.
Yeah, 6 plus 2, 6, 7, 8. It's 8. What is 3 plus 4? 7. Guys, look at that. 3 plus 4 is 7. We needed it to add up to B. Our B is 7. So this right here, 3 and 4, are going to be the 2 numbers we use. Okay? So since we have a positive 3 and a positive 4, all we do is write plus 3 and plus 4. And guess what? That's your answer. That's it. It's really not so bad. And we're going to do a million practice problems until this is like second nature to you guys. You're going to be doing this in your sleep.
So what we're gonna be doing is always finding the constant.
Yes.
But we need it to be partnered
With the
B.
Yes, you just want to find all the factors of your constant or of C, and whichever set of factors adds up to your B, or your 7 in this case, that's where you fill in your parentheses. So now, guys, we could also check our answer. Whenever I multiply x plus 3 times x plus 4, I should get x squared plus 7x plus 12. So for fun, let's do that. Let's do our box method. Let's just make sure we did it right. So I'm going to write x plus 3 on this side up top, and then x plus 4 on the outer edge, just like this. And what's x times x? X squared. And then we've got our x times 3, which is 3x. Then we've got x times 4 is 4x. And 4 times 3 is what? 12. So, guys, if we combine our like terms, 4 plus 3 is 7. So I can write it out as x squared plus 7x plus 12. And look at that. We know we did it right because we got the same thing we started with. Okay. Isn't that cool? It's not so bad. It looks really scary, but when we break it down, it's not so bad. You guys can do it. Okay. Let's do some more examples. I'm going to let you guys write this down. If you're still writing, take your time. I'll pause it.
Yeah, I failed the first year.
All right.
Half-half.
So-
And then I took summer school for the last semester.
Here is our worksheet. I am actually going to write these on a separate page because I don't know. It's kind of tiny. So let me lift this up and I'm going to title a new page, Day 5 continued again. Okay. Day 5 continued. Just have to do this to stay organized because I write on so many papers all day long. If I don't label them, they get lost. Okay. And this is Algebra 2.
If I don't label it, then I'll put I have no clue what it is.
Exactly. That's what happens to me. And I'm going to also write that. I'm just going to factoring this time.
And it's math, so sometimes it looks like a whole bunch of language.
Right? I mean, it really is a whole different language. Math is a different language. It is a total, and you know what? Y'all are speaking it right now. You're doing it. You're doing really well. Okay, so
Like the production.
I'm gonna write factoring. A lot of writing. You guys don't have to write this if you don't want to, but I'm doing it for my own peace of mind. Factoring quadratic expressions. I'm going to label this A because I actually printed off 3 versions of this worksheet so you guys can have more practice later on. There's A, B, and C. This is A. Okay. So let's look at number 1 together. We've got x squared. Now this one's got some negatives in here, so we'll see how that works. X squared minus 4x minus 45. Okay. So first of all, I like to label my A, B, and C. So my A is what? 1. It's 1. There's an invisible 1 next to x squared. What's my B?
-4.
Negative 4 is B. Just negative 4. And what's C? Yeah, negative 45. So I like to have those written out first. We want to get really good at identifying what those coefficients and constants are. So once we've got that labeled, if we look back at that little guide we just made, what's step 1 tell us to do? Yes, we want to go ahead and write our 2 empty sets of parentheses. Not totally empty though. We do have x plus or minus something times x plus or minus something. So I'm going to do that. X something and then x something.
Would your x still be squared? Or
So we have just
it's
x.
because those two are,
Because whenever we multiply this out, these are going to be 2 binomials, just like what we've been doing where we multiply with the FOIL method or the box method. We're going to end up doing x times x to get x squared.
okay.
So if we put x squared in here, we would end up with x to the 4th power. Yeah, so we're just going to have x and x. Because remember, when we're factoring, we're finding what do we multiply to get to this. We're going to multiply these 2 types of things, just like we've been doing the last couple of days. So our first step is to write those parentheses. Step 2 is we're going to be finding numbers that multiply to negative 45
That's where the teacher.
and that add to negative 4. Let's just worry about the multiplication part first. So
3 times 15.
Yeah, let's start over here. I'm going to write negative 45. And we could start by writing 1 times negative 45, but I know that's not going to add to negative 4. But we'll write it just for fun. 1 times negative 45. Okay, can we divide negative 45 by 2? No. I heard 3, and what was the other number? 3 times negative 15. Can we do 4?
No.
No.
5 and 9.
Negative 5 half by 9.
Yeah, 5 times negative 9. Any other numbers we could do? We can't do 6. We can't do 7. Can't do 8. And then we're back to 9.
Yeah.
Okay. So we've got all the number values. We know one's going to be positive, one's going to be negative. We could also write out all the ones, negative 1 and positive 45, negative 3, positive 15. But before we do all that, let's just see if we came up with an answer already. So I don't want to jump too far ahead. Is everybody with me to this point? Do we understand what we are doing here? Is anybody lost?
Trying to get the answer 45.
Yes. Good. Okay, so here's all of our factors of 45, negative 45 that we're looking at so far. So remember, I am trying to find out which of these sets of factors are also going to add up to negative 4. So let's just start adding them together. What is
5 times 5.
1 plus negative 45? Or we could just say 1 minus 45.
44.
Yeah, negative 44. What's 3 minus 15?
I see this one.
Yeah, negative 12. What's 5 minus 9? Negative 4. Oh my gosh, look at that. Negative 4. So guys, what are we going to write in our parentheses?
5 and negative
X
9. Plus 5.
X minus
Yes, if we have a positive number, we would put plus.
X plus 5.
And a negative number, we put minus. So x plus 5, x minus 9. And guys, that is your answer. Yes.
So whenever I was doing this ahead of you and I did negatives first on this, under my T, I did negative 1 number. So I got negative 5 and 9. Is that okay? You know, let's switch. Or would it
So
be
let's see.
come out to be a different answer?
That's a good question. Okay, so guys, let's go over this question real quick. What if we tried negative 5 and positive 9? What is negative 5 plus positive 9?
4.
Positive 4.
Positive 4. So is that RB, is that the same?
No.
No, it has to be the same sign. So if you get the right number, but the wrong sign, just flip flop which one's positive and which one's negative. So if I know that I've got 4, but it needs to be negative, just make the bigger number negative instead. That would be the 9 in this case.
Does it matter which order they're in the answer?
No, you could just write x minus 9 and x plus 5. It doesn't matter which one comes first, as long as you have a plus 5 and a minus 9. Good question. Any other questions? We're going to do more together. Any other questions?
I think I did 2.
You got number 2? Okay, well, we're about to work that one out, and you tell me if you got it. All right, can we go to number 2, guys? Let's try another one together. Number 2 is, I'm going to write it out, x squared minus 5x minus 6. So, A is 1, B is -5, C is -6, and yes, I heard somebody say it, write your parentheses. Go ahead and you're going to have x plus or minus something times x plus or minus something. Oh, hey guys, it's lunchtime. Ah, I'm so glad I looked at oh, actually, I think we have like 2 more minutes. Yeah, we do. Let's finish this problem and then I'm going to send you off to lunch. Okay, so what number are we trying to find the factors of first?
6.
-6. Good. So let's write out all the numbers we could multiply together to get -6. I got 1 and -6, 2 and -3. Yeah, and then 3, -2. And then we'll keep going if we need more, but let's check these already. Okay, so remember I've got my factors of -6, and then what do I want my numbers to add up to? Yes, I want it to equal B, -5. So let's go ahead and check our first line. What is 1 plus -6?
-5.
Oh my gosh, -5 on the first try. So what am I going to write in my parentheses?
1 plus 1 -5.
Oh,
I mean, -6.
yeah.
I got the answer right on my paper.
You got it. Guys, that's it.
That's pretty easy.
It's not so bad. It's not so bad. Okay, that's all we're going to do before lunch. Please come back after. We're going to do some more practice together. Get really feeling good about this. You guys are doing great. You're doing great. I'm going to pause this for now. Okay, back from lunch. So, number 3, we have x squared minus 17x plus 72. So whenever we are factoring quadratic expressions, remember we're looking at our A term, our B term, and our C term. So what's our A here? What number's attached to x squared? 1. Good. What's our B?
-17.
Good. -17. And what's our C? 72. Okay. So first step, whenever we are factoring a quadratic expression, what's our answer going to look like? Yeah, we're going to have 2 sets of parentheses with x plus or minus something in both of them. Just like that. So, to figure out what is going to go with our x's, what should we start by doing? Yeah, we want to figure out all the factors or all the numbers that multiply to 72. So let's start by writing 72 and making a little T chart of all the numbers that we could multiply to get 72. So we'll start with the most obvious one. We got 1 times 72.
8 times 9.
2 and 36.
6 times 12.
Okay, here, let's go real slow and in order.
Okay.
That's all right. So we got 1 times 72, 2 times what? 36. Can we do 3?
3 times 24.
3 times 24. Can we do 4?
4 times 18.
4 times 18. Can we do 5? I don't think we can. 6?
Times 12.
6 times 12. Can we do 7?
No.
Can we do 8?
8 times 9.
8 times 9. And we already got, oh, here, let me move my screen down. If we move to the next number, which would be 9, we'd do 9 times 8. We already have 8 and 9, so we're going to stop there. Okay, so we have all the factors of 72. Now, we want to add all these numbers together one by one, each set, and let's see which of these sets are going to add up to negative 17. What's 1 plus 72? 73. 2 plus 36? 38. 3 plus 24?
27.
27. 4 plus 18?
22.
22. 6 plus 12?
18.
18. What's 8 plus 9? 17. Okay, so we know 8 and 9 are probably the numbers we're going to work with. But what's our B again?
Negative.
Negative 17. 8 plus 9 is positive 17. What other numbers could we use instead?
Negative 8. Negative 9.
Yeah, let's just do the negative versions of those numbers, because negative 8 times negative 9 still gives us positive 72. But negative 8 plus negative 9 gives us negative 17. That's the answer that we need. So since the numbers that we're going to multiply to get 72 are negative 8 and negative 9, what do we do with those?
Put them in our parentheses.
All you're going to do is take those numbers and put them in your parentheses. X minus 8, X minus 9. And that's your answer. That is your answer. And how can we check our answer to make sure we got the right factors? Yeah, we could just multiply these together and make sure that it multiplies to x squared minus 17x plus 72. You just do the FOIL method or the box method. Either way would work. Okay, do we have any questions about number 3? Any questions? Okay, let's do one more together before I set you guys off on your own, and then I'm going to be around to help. Anybody still need this? Can I go to the next page? Is anyone still writing? Okay, I'm going to tear it off. So let's look at number 4 now. This one's a little different. Okay, number 4, I have x squared minus 36. Okay, so since this is different, we need to think about what our A, B, and C are and see what's going to happen there. What's A? Oh, okay, so let's not get this mixed up. Remember, the A, B, and C are the numbers attached to the x squared, the x and the by itself. We don't want to include x. So what is A? 1, not 1x squared, it's 1. A is 1. Remember, the B is the term attached to x. So what would our B be in this example?
0.
0. If there's no x, 0 times x would get rid of the x. So our B in this case is going to be 0. There isn't a B.
Made me question myself.
Who is confused about that?
Me.
Okay, so let's talk about that for a minute. We have ax squared plus bx plus c. Okay, so if my a is 1 I'm gonna write 1x squared plus, if my b is 0, I'll put 0x.
No middle.
And what's our c?
36.
36.
Okay.
So if I were to simplify this here,
Minus.
oh yeah, negative 36. My bad.
Oh,
I messed that up.
I messed up.
So let's see. If we have 1x squared, we could just write that as x squared plus 0 times x. What's that? 0. If you take anything times 0, it makes it disappear. So it's gone. And then we've got minus 36. And you see how this is the same as that original problem? It's the same thing. So that's why we got b as 0. Okay. Is anybody still confused about that? Okay, good.
So what's our answer?
So that's not our answer. I was just showing you why b is 0. We still got to factor it. Okay? So remember, whenever we are factoring a quadratic, what number, or where are we going to start first of all? Say it again. Yes, we want to start with our 2 sets of parentheses with x plus something or minus something and another x plus or minus something. So now, what should we do next?
Plus 1.
Yeah, let's figure out our factors of c, of negative 36. So here's where we'll make that T chart. Negative 36.
Yeah.
Okay, so let's start. And if you're already starting to get a sense of what numbers will and won't work, you don't have to write them all out 1 times 36 or 2 times I'm just showing all of them so everybody sees where they're coming from. So I could do 1 and negative 36, 2 and 18, is that right? Negative 18. Yep, 3 and negative 12. 4 and negative 9. Can't do 5. 6 and negative 6. And let's stop there. Okay, give you guys a minute to get that written. Okay, so we have some factors of C here. What should we do with these factors now? Yeah, let's add them together and see if any of them come up to 0. Remember, we want them to add to B. Our B is 0. So,
Negative 6 and
yeah, without even doing all this work, I know 6 minus 6 is 0. So, let's circle that. We know that these are going to be our numbers. I've got positive 6. I've got negative 6. So, we can write in our parentheses, what are we going to write?
Plus 6 minus 3.
Yeah. X plus 6, x minus 6. Oop, why did I write 2? I don't know. My hand had a mind of its own just now. X plus 6, x minus 6. Awesome. Okay. Any questions about this one? All right. So what I'm going to do is I am going to put on the board picture of this worksheet that we are working on. I want you guys to just keep going down the worksheet, working on those problems. I will come around, and if you need help, give me a look and I'll come help you. But I'm going to put this up here so that anybody that isn't here can see the problems we're working on. And I'm going to set like a 20-minute timer while we work on these, and we'll come back together here in just a bit. So let me pause.